1.5, segments and angle bisector. Definition, midpoint. The midpoint that divides or bisects a segment into two congruent segments. Here we have M is the midpoint of line segment AB. That makes AM congruent or equal to MB. We like to put these markings here to show that I have this line segment AM congruent to line segment MB. Remember, in geometry, you need to write equations to be able to solve for X. Here is a free piece of information when I have a midpoint that gives me two congruent segments, which means I can write an equation and solve for X. We also have a segment bisector, a segment, ray, line, or plane that intersects a segment at its midpoint. Here is the midpoint, and we can see that line CD is a bisector of line segment AB. Again, because this line is bisecting at the midpoint, we know that AM is going to be congruent to MB. Example 1, find the coordinates of the midpoint of AB with endpoint. A is -2, 3, and B is 5, -2. Remember, in our condensed notes, we have the midpoint formula. Midpoint equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, and this is a midpoint, so we write it as a point. Here we have x1 and y1, our first point. We have x2 and y2, our second point. The midpoint equals -2 plus 5 divided by 2. I'm adding up my x's. And my y's would be 3 plus -2 divided by 2. -2 plus 5, or 5 minus 2 is 3 halves. 3 plus -2 is 1 half. And there's our midpoint. My fractions are simplified, and I can leave them as improper fractions. Finding the coordinates of the endpoint. So here in this example, we had a line segment, AB. They gave us the coordinates of the endpoints, and we were looking for M, the midpoint. On the next example, we're looking for one of these endpoints. The midpoint of Rp. We have R is -1, 7. And then we have the midpoint. The midpoint of Rp is, this time we know what the midpoint is. We are looking for the endpoint. We have x1, y1, and we are looking for x2 and y2. We don't have the second point. We have the midpoint, and we have x1 and y1. We're looking for x2 and y2. Our midpoint, we're going to take the x, which is 2, and set it equal to the x part of the midpoint formula. That would be x1 plus x2 divided by 2, and then we're going to take the y value 4 and set it equal to the y values of the midpoint. We know what x1 and y1 are. We're going to substitute in that first point. X1 is -1. Y1 is 7. And now we have two simple equations to solve to be able to find x2 in this equation and y2 in the second equation. I am focused on how to solve for x2, and I would like to undo the fraction that we have here. I'm going to do the opposite of dividing by 2, which will be multiplying by 2. If I make this to a fraction, I can see that 2 in the numerator is canceling with 2 in the denominator. 2 times 2 is 4. -1 plus x2. And now I have a one-step equation where I need to get x2 by itself by adding 1 to both sides. And we found that x2 equals 5. I'm going to do the same thing on this equation. I'm going to multiply both sides by 2 to get rid of the fraction here. 2 in the numerator, canceling with 2 in the denominator. 2 times 4 is 8. 7 plus y2. And I'm going to finish solving for y2 by subtracting 7 to both sides. We found that y2 equals 1. Now I have x2, y2. The second coordinate of the endpoint is going to be 5, 1. That is the missing endpoint, x2, y2. Definition: an angle bisector, a ray that has an endpoint and goes with an arrow on the end, a ray that divides an angle into two adjacent angles that are congruent. We know that if I have an array that is bisecting angle ACB, that means that angle ACD is going to be congruent to angle DCB. And we can show those markings. They have the same markings. Therefore, visually, when I look at it, I know that these two angles are congruent to each other. Again, there's that equal sign to be able to write an equation. We have midpoint to write an equation. We have an angle bisector to be able to write a congruent equal equation. Example 3, the ray FH bisects the angle EFG. So if I make angle EFG, EFG, ray FH. The endpoint is at F, the continuous end is at H. Here's F, the point. And here is H. Ray FH is bisecting the angle. Therefore, I know that the first angle is going to be congruent to the second angle. These angles are congruent. Given that angle EFG equals 120, EFG, the entire angle, equals 120 degrees. What are the measures of angle EFH and HFG? EFH. If the entire angle equals 120 and it's been bisected, how much will angle EFG? It's been bisected, so that must be 60 and 60. They are equal to each other. 60 degrees, and angle HFG also equals 60 degrees. Example 4, doubling an angle. In the kite, two angles are bisected. EKI is bisected by KT. EKI is bisected by KT. That means that this angle here, notice that the K is in the middle. That is the angle that we're talking about, EKI. K is in the middle, and we're looking at angle K here. EKI. This angle here has been bisected. That means if this is 45, the second angle will also be 45. Angle ITE, ITE, T is in the center. We're talking about IT, the angle, E is bisected by TK. That means if the first angle is 27, the second angle will also be 27 degrees. Find the measures of the two angles. Angle EKI equals 45 and 45 is 90 degrees. And then angle ITE, 27 and 27 is going to be 54 degrees. Doubling the angle. And finally, for some algebra. In the diagram, ray RQ bisects angle PRS. PRS. That means that the first angle is going to be congruent to the second angle. They are equal to each other. The measures of the two congruent angles are x plus 40 degrees and 3x minus 20 degrees. Solve for x. If I'm going to solve for x, I need an equation. We're looking to create an equation. What is equal to what? We have angle PRQ, which is x plus 40, is equal to the second angle, 3x minus 20, QRS. And there is our equation to solve for x. I'm going to start by focusing in on my variable and combining those together. I'm going to move the smaller x over to the larger x. The opposite of positive x is negative x. 3x minus x is 2x. Now we have a two-step equation. I'm going to start shifting the negative 20 to the opposite side by doing positive 20. And finish solving for x. Divide both sides by 2. We get x equals 30. Read the directions. Are we looking for an angle or are we solving for x? Solve for x. If I wanted to know how much angle PRQ is, how much would it be? X is 30. 30 plus 40 is 70. If I wanted to know how much QRS is, how much would that angle be? It would also be 70 because they are congruent to each other.